In today's lesson, we're going to look at how to simplify Boolean algebra. Look at this expression. What will A and not A always result in? And why is this the case? Try these using your logic boards. In your exam, you're actually expected to be able to simplify Boolean expressions. You might be given an expression like this: not P or not Q, and not P or Q. It could also be asked for you to write it in the simplest form. It's actually always quite challenging to begin with this topic, but there are actually a number of rules and laws which can help us to simplify Boolean expressions. You're going to need to learn these. However, they're best actually known by practicing. Let's remind ourselves of a few of the various logic gates and their notations, just to ensure that we're happy with these. Task number 1. See if you can link up all the different laws. Change the colours of the boxes and we'll have a look at the answers shortly. Here are the answers. Did you get them all correct? So let's have a look at some of the Boolean laws that you're going to have to know. First of all, the commutative laws. A or B equals B or A, and A and B is equal to B and A. You'll notice how we're using 3 equal signs here to show equivalence. Actually, the order doesn't matter in these. A and B is the same as B and A. If we are adding up 2 plus 4, it's exactly the same as saying 4 plus 2. It doesn't matter which order we have them, they're always going to give the same results. Let's have a look at the next set, the distributive laws. In this example, we can think of these a little bit like having brackets in maths. A and B or C can equal to A and B or A and C. And we can also put something back into brackets. Now notice this is when we have our ors and our ands. So A or B and C can equal to A or B and A or C. So whenever we've got these brackets, just be careful. Look at these different structures and we need to use these. Now the next two should hopefully be common to you already, the associative laws. We've got A or B or C is exactly the same as saying A or B or C. You can see that we can move the brackets. It doesn't really matter. Think about when we've got 3 inputs. If we're using an OR, we can simplify that and remove those brackets. It's actually the same when we've got ands as well. It doesn't matter where the brackets are there. A and B and C is exactly the same as saying A has to be on and B and C. The brackets are not needed in these instances. If we look at the bottom, we've got a set of AND rules and a set of OR rules. The AND rules state that A and 0 is always going to give 0. If one of our inputs is 0, well, it's going to give a 0 output. It can't give a 1 because when we're using an AND, they've both got to be true for an output. So it's 0. If we have A and 1, well, that's just the same as saying A. If we have A and A, well, again, that's just the same as saying A. And A and not A is 0. Think of your maths there. Our OR rules, A or 0 is A, because one of those two values is on. It's A. A or 1 is 1. A or A is the same as saying A, and A or not A is the same as saying 1. Now there are a few other rules here. The Morgan's law. De Morgan's law says that if we've got a not outside a bracket, we can reverse the sign and add a not to both of them. So you can see A, so not A or B gives not A and not B. And De Morgan's law also tells us that not A and B is equal to not A or not B. There are a few other rules. Not, think of two negatives gives a positive, so not A gives a positive. A or A and B is A. A or not A and B is A or B. It's just a fact of remembering some of these laws. So I want you to work through these in your workbooks now. We'll have a look at the or, the and the other rules. Now the first thing to realise is not 1 is 0 and not 0 is 1. So they are opposites of each other, and we can think of them a little bit as having small circuits. If the circuit is completed, it gives us a 1. And you can see the circuits included in this workbook. Let's have a think about A or A and A and A. Well, in both these situations, the answer is just going to be A. If we look at A or not A and A and not A, they both give a slightly different outcome. So A or not A is actually going to give us 1. And A and not A is going to give us a 0. We need to remember these rules because we are going to be using them again and again when we simplify rules. Now we can also think of two nots. So not A or not A. Well, that is also going to give us not A. Now I want us to think of when we're using A and using 1 and zeros now. So you can see down the right hand side we've got our rules and you've got 4 different options here, and it's just about learning these. So A and 1 is A. A or 1 is going to be 1. A or 0 is going to be A. A and 0 is going to be 0. And the final one really is not A. Well, this is a double negative. So when we have not A, it's going to give us A. Now, just a note on the other rules at the bottom, you can see in the other rules. We've got rules such as A or A and B equals A, and A or not A and B is the same as saying A or B. Just a little bit different rules. I want you to try completing the workbook now, and we'll have a look at the answers. So here are the answers. Check your answers and make sure you've got them correct. Think very carefully about the outcomes and why each expression gives that outcome. We need to make sure we've learnt these expressions before we move on. Now let's look next at the distributive laws. Now before we do that, we've got to think very carefully using maths how we can expand and factorise brackets. We can use several laws together like we're showing on the screen here. So you can see not P and P or Q. Now we can multiply out these brackets. So let's think about this. Not P and P, or not P and Q. Now when we've got not P and P, we know that is equal to 0. So not P and P equals 0. We can then simplify that a little bit more. We don't need the 0 now because it's 0 or. We can just use our distributive laws to go not P and Q. Now notice how we multiplied out and distributed the top line. This is just our distributive laws. So we just multiply them out together. So when we have an and with the brackets, like we do in maths, we would just put ors in between them. So you can see the one highlighted on the screen here. It gives A and B or C. We can turn that to A and B or A and C. Now the distributive laws actually say that you can eliminate one input if it's in two parts of the expression. And actually sometimes it's easier for us to draw out the truth tables to help us. Now the first statement, not A or A and B, actually can just be written out as not A or B. And to show this, I want you to find page 4 in your workbooks and complete the truth tables. You can see as we do this, we do not A, and if we look at A and B, we can then represent that as not A or A and B. So try this task first. So here you can actually see the results. You can see that both logic gates actually give the same result. So it's about us trying to figure out what the outputs would be to make it simpler sometimes and to check our understanding. Here you can see the answers for A or B and C. If you look at the logic gate and the outcomes, we've got 3 zeros followed by the rest ones. But if you look at this outcome here, actually it's the same, 3 zeros and the rest ones. Now it might look more complicated here, but actually look at the engineering. We only need 2 logic gates, meaning it's simpler to engineer. Now the commutation laws means that the order of 2 terms within an expression is not important. Think of it like this. If we have 2 plus 3, that's equal to 5. But if we have 3 plus 2, that's also equal to 5. You can actually also move inputs either side of an and or an or. So here you can see our laws. A or B equals B or A. A and B equals B and A. Have a go at these tasks inside your workbook. And here are the answers. Check your answers and make sure you've got them all correct. The association laws look quite complicated to start with, but they're actually really simple. They allow for the removal of brackets from an expression if all the operators are the same. They must all be the same. You can see here we've got A or B in brackets or C. That's exactly the same as saying A or B or C without brackets. It's exactly the same with AND. Try and complete the task in your workbook. Here you can see the answers. The first one we've got A or B and C in brackets gives the following result. A 0 at the top and the rest are in ones. So here's the same expression, but this time using the association law with the brackets removed. On this one here, you can see that it's exactly the same output. So here you can see the answers to the results of the association rules. Check you got them correct and make any improvements when needed. De Morgan laws state that or and and can be swapped by making certain changes to expressions. So for example, not A or B can turn into not A and not B. And also you can see here that not A and B is also equal to not A or B. Can you complete the 4 pages in your workbook? So here you can see the two expressions give the exact same result. Not A and not B is the same as saying not A or B. But actually in this case, not A or B is better because there are less components. So the second circuit is more preferable. This means that it's going to save us money and the engineering is going to be much easier. Again, in a similar way, here are the answers. You can see that the second option is much better because of those circuits. Here are the answers for the De Morgan's Law's second task. Check that your answers are correct and make changes when needed. And finally, this was a little bit more complicated. Not A or not B and A. We know that from De Morgan's law that we can change the symbols. Not A or not B is going to give the same output. So here are some examples. See if you can figure these out yourself first from the expression at the top. So first of all, you can see not P or Q and not P or Q. We can use De Morgan's law on this. So we can get rid of the first set of brackets. So we can change it to have an and. It makes it much more easier because we've just got ands if we can get them all to the same type of logic gate. So not P and not Q. We can then multiply out the brackets using the distributive laws. So not P or not Q can equal to the following, which is shown on here. So we have our not P and not Q and not P, or not P and not Q and Q. We can simplify this using some of our general rules now. So not P and not P just equals not P. So where we've got two not P's, we can just change that to not P and not Q. We know that not Q and Q equals 0. So we can change that to 0 as well. We know that not P and 0 equals 0. So we can just remove that. It's just equal to 0. Leaving us with not P and not Q. To help us, we can make the truth tables for this. Make the truth tables for the top statement and the bottom statement and check that you are correct. So here's a new expression. Before we start though, I want you to make the truth table for the top expression. Let's see if we can figure out what the simplified version would be just from looking at the truth table. So first of all, let's use De Morgan's law. We've got not P and not Q. So we can remove the brackets and turn that into an and. Not P and Q. And inside the brackets, we can now multiply them out. Remember, we multiply everything outside the brackets by what's inside the brackets because we've got our and there. So not P and Q and not P, or not P and Q and Q. We know that not P and not P equals just not P, so we can put that back into there. We can now also do the same for Q. So Q and Q is just Q. So this gives us not P and Q, or not P and Q. So not P and Q, or not P and Q is just not P and Q. And there's our answer. Make the truth table for not P and Q. Does it give the same output? Again, here's the last one. I want you to try and simplify this equation. Before you do that though, make the truth table. See if you can figure it out using the truth table. Now the first thing, again, we use De Morgan's law. You can see we've got a not there, so we get rid of the brackets and we invert the sign. We can apply the distributive law. We can then figure out that not Q and Q equals 1, not P and 1 equals not P, not P or not P equals not P, and we end up with not P or not Q. Draw the truth table and check that this is correct.